So today's lesson is going to be on a combustion reaction. And a combustion reaction, according to our reference tables, is the fifth type of reaction where we have a hydrocarbon plus oxygen yields carbon dioxide plus water. A hydrocarbon, that is a carbon with a hydrogen. Hydro for the hydrogen, carbon for the carbon. So we have a hydrogen and a carbon. There can be other stuff. So look at number 3. Number 3 has this oxygen in it, but it's still a hydrocarbon because it has hydrogen and it has carbon. A combustion reaction is truthfully anything that burns in the presence of oxygen. But for the purposes of our class, we're going to stick to only hydrocarbon reactions in terms of combustion. All right, these problems, I think, are the most basic in terms of writing the products because you have the hydrocarbon, which provided, oxygen is always a reactant, and then your products are always carbon dioxide and water. Now, I think these problems are also the most challenging to balance. If you can balance combustion reactions, you can balance any reaction that I give you. All right, so I have one carbon on the left and one on the right. Okay, I'm sorry, I wrote that wrong. I have 3 carbons on the left and 1 on the right. So I'm going to take this 3 from the carbon and I am going to put it in front of the carbon. Now I'm going to save oxygen for last because I can balance my hydrogens, but when I balance the hydrogens on the product side, this oxygen will change. When I balance my oxygen on the reactant side, nothing else changes. So I'm going to save my oxygen here for last because it's going to make my balancing easier to do. I have 4 hydrogens as a reactant, and I have 2 hydrogens as a product. So I'm going to put a 2 in front. Now let's look at my oxygens. 2 times 3 is 6. So I have 6 oxygens plus 1 times 2 is 2. So I have a total of 8 oxygens. So I'm going to put a 4 in front of this oxygen, and now I am balanced. So let's do us another problem. All right, my hydrocarbon in this case is C2H6. In the presence of oxygen will yield carbon dioxide and water. All right, now I'm going to do this in pencil because sometimes chemistry requires an eraser. All right, I have 2 carbons on the reactant side, so I'm going to put a 2 in front of the carbon. Again, I'm going to save my oxygens for last. I have 6 hydrogens, so I have to put a 3 in front of my water. Now let's look at my oxygens. On the product side, 2 times 2 is 4, plus 1 times 3 is 3. I have 7 oxygens. So here's where it gets a little tricky. What times 2 is 7? 3 and a half. 3 and a half times 2 is 7. However, can I have half of an oxygen atom? And if you answered no, then that is correct. You cannot have a half. So what am I going to do? I am going to multiply this entire reaction by 2. So 1 times 2 is 2. 3 and a half times 2 is 7. 2 times 2 is 4. And 3 times 2 is 6. All right. So sometimes it's easier to balance with a half and then go back and multiply the entire thing or the entire reaction by 2. All right, let's check out C4H9OH. All right, in the presence of oxygen is going to give me carbon dioxide and water. Now this one gets a little bit tricky to balance as well because you have to pay attention. You have hydrogen in 2 spots and you have oxygen in 2 spots on the reactant side. You also have oxygen in 2 spots on the product side. So let's start with carbon, working left to right here, saving our hydrogens and oxygens for last. I have 4 carbons, so I'm going to put a 4 in front of my carbon dioxide. I'm going to go ahead and balance my hydrogens, again saving oxygen for last because oxygen here is by itself. 9 plus 1 hydrogen is 10 hydrogens, so if I put a 5 in front, 5 times 2 is now 10 hydrogens. What about my oxygens? On to the product side, 2 times 4 is 8, plus 5 times 1 is 5. So 8 plus 5 is 13. That is an odd number. Now, we are not going to put a 6.5 in front here. 6.5 times 2 is 13, but I don't want to do that because, remember, pay attention, you have this oxygen. So if I have 13 total oxygens on the product side, and I have 1 oxygen from here, that leaves me 12 remaining hydrogens 12 remaining oxygens that I need. So I have 13 oxygens on the product side, and 1 here, so I need 12 oxygens. So 6 times 2 is 12.